Okay, so the official goals for today is to talk about quadratics. Like you'll be able to look at one and go, well, duh, that's a quadratic. And that I'm going to just do in 2 seconds. If it's got the biggest degree on it is an x squared, then that's a quadratic. And it makes a U shape. So if you see a graph and it kind of looks like that, not a V shape, a U shape, then you got a quadratic. All right, identify the vertex of a parabola. Well, duh, there it is. But you have to be more like, what if you give you an equation? How do you find the vertex? And then identify the axis of symmetry. That's this little dotted line that runs down the middle of the parabola. We're going to remind you how to do that. All of those things are higher algebra skills. And there's one more thing that they don't list, but I know we're going to test you on eventually, is if I give you 2 points on a parabola, like I give you the vertex and one other point, you'll be able to write the equation for the parabola from just the vertex and one other point. All right, the only thing that's tricky about that is knowing how to write vertex form of a parabola. And then we have to do this little process where we figure out, is there a stretch or not? Do you get if you go over and up, you're always going to have a point there. But if you had a stretch factor, it's kind of hard to tell. All right, so there's a big overview of what we're doing today. This is vertex form of a parabola. They usually put an h and a k in there. Please write this next to it. Y equals 3 parentheses x minus 2 squared plus 7. And then the vertex is buried right here. Everybody, if you haven't written that down yet, write it down because I need to remind you. And this part improves the probability your brain will remember this by writing it down. Activates a different part of your brain that has better memory. 2 comma 7 is the vertex. Notice I didn't say negative 2. It's the opposite of the number inside. And then that number on the outside, that's the vertex. There's only one vertex on the whole parabola. It's like the most important point. You know what? There's an infinite number of points on a parabola, but there's only one at the very bottom of it. Or if you flip it over, there's only one at the very top of it. All right, so that vertex form is really important. This is called the stretch factor. And is the parabola normal or is it like stretched like this? Both of those have the same vertex, but one of them's stretched. And that's what that number in front does, that 3 there. Okay, so if I give you an equation, you're supposed to be able to go, I know exactly where the vertex is, and I know if it's been stretched or not. All right, so I'm going to do that. Write this down. Y equals parentheses x minus 1 parentheses squared plus 6. Do you know the vertex? I do. I showed you. Was one example enough? I hope it was. What's the vertex on this thing? Brady. Comma. Yep, that's the vertex. So if you were to graph it, you'd go over 1 and up 6 and put a dot, and then it's a parabola that goes like that, through that little vertex right there. Am I going too fast or is this good? You getting this? Okay, now, would you agree that there's a line that runs right down the middle of parabolas? That's called the axis of symmetry. You've got one on your face. Runs right down through your nose. You have an eye on each side. Your lips look the same on each side. You got an eyebrow on each side. You got an ear on each side. So you have an axis of symmetry right down the middle of you. Okay? That's just called an axis of symmetry. One of my kids called it the excess of symmetry, which I kind of like because then it reminds you this is an x equals number. And since this is the x of my vertex, it's at x equals 1. You know, if I numbered this along here, it'd be like 1, 2, 3, and it's at 1. It makes sense. It goes right through that point right there. That was the vertex, 1 comma 6. So the x equals 1 is the axis of symmetry. So whenever you know the vertex, you instantly know that's the axis of symmetry. The x equals 1. And when I say x equals, that's a line. That's a line like this. Looks kind of like an asymptote. It's a vertical line. There are no asymptotes for parabolas that like run this way. They're always vertical. So it won't be like that blue one. It'll be like the red one. All right, so if I said, here's the vertex and it's 2 comma 9, you should be able to go, well, x equals 2 is the axis of symmetry. Boom. It's that quick. All right, but could you write the equation for this? Everybody try that. It's just going backwards. And if I know what the vertex is, then I should be able to write the equation for this. In a second, I'm going to ask you to show the equation that you wrote using this vertex to the kid next to you. You guys have a little group of 3 here. You guys have a little group of 3 here. You guys have a group of 3 right here. Just compare with each other, and if you don't understand, ask the kid next to you. So some kids forget the squared. X minus 2, notice I did the opposite, and then plus 9. Raise your hand if you had that one right. Cool. All right. Now, notice I never said anything about the stretch factor. If I don't know what the stretch factor is, we call it A. You don't have to put that there, but just so you know, there is some mystery stretch factor there. Now, what if there isn't a stretch factor? Then is A 0 or is A 1? It would be 1. All right. So if I don't know what the stretch factor is, I guess I could kind of just assume that there wasn't any stretch factor and put a 1 there. All right, now that brings me to the hardest thing for the day, and I'm going to hit it you right now because I feel like your brain's warmed up a little bit. We're about 10 minutes in. You're a little smarter than you were when you first got here. Could I possibly tell you the hardest thing that we're going to do today? So if that spot right there, make this little picture, and that's going to be at 4, 1, and label it like that. Well, if there is no stretch factor, then we wouldn't even give this to you. It'd be too easy. The equation is x minus 4 squared plus 1. But what if there is a stretch factor? The way we do it is we tell you another point that's on it, and we'll say, well, the point 5, 2 is on it, and here's how you then figure out what the stretch factor is. There will be a stretch factor. Worst case scenario, the stretch factor is 1, but we're going to always give you one that doesn't have a stretch factor of 1. It'd be too easy. So, how do you do it? Let me just show you. I'll just walk you through one. Would you agree that I've written the equation right in the first place? I put the 4 and the 1 that were from the vertex. I put them in the right spots. You with me so far? Okay. Then, would you agree that I do not know the stretch factor, so I'm going to put an A here. You get what I mean by that? I don't know what it is. I got to get some letter for it, so I'm using A. And the last thing is, what the heck do I do with the 5, 2? Somebody in here is going to be smart enough to figure this out. Take a guess. Guess.
Do you put it in the form that we did yesterday?
So where in this, it's going to go in here somewhere. Where in that should I put it? And I know what you're thinking. You're thinking of that y minus y1 equals mx minus x1. That's if it was a straight line. That's a very good point. If it was a straight line, we would use that. We'd have our point, and we could put it in here and here. But that's for straight lines. Thanks for bringing it up. It was a very good point. It would be perfect if this was a straight line, but it's a curve. Yes?
Do you put so like x is 5, so you put that for x?
X is 5, you put that there. Keep going.
And then 2 for y.
Y is 2, so you put that there. I'm going to rewrite it now, because that just became a 2. Because why? Because that's the y value. So 2 equals A, parentheses, and the x of it was 5, and that went there. 5 minus 4, parentheses squared, plus 1. And look at that. That's an equation that only has A in it. And that means I can solve it and figure out the stretch factor. I can figure out what A is. All right, so everybody do that right now. Just solve that. It's not that hard. Start here. What's 5 minus 4? 1. 1 squared is 1. Keep on going and solve it. Get A alone. This is just algebra. 1A, isn't 1A just pretty much A? I mean, that was all just a 1 squared, which is just a 1. I could put a 1 here, but do I have to even put a 1 there? No. 1A is the same thing as A. And then I'm going to subtract 1 from both sides. A equals 1. This had a stretch factor of 1. All right, I was telling you that that would be a little too easy. Well, it's our first one, so it should be pretty easy. All right, let's do another one. Ready? Make a parabola. This time, this is going to be at 2, 1, right there. And what's the name of that spot? Vertex. Now I'm going to give you another point that's on it. Five comma 7. Actually, sorry, 7 comma 5. Switch them. 7 comma 5. I'm just trying to make it match my picture. It looks to me like it's over more than it's up. So, okay, so this is going to have a crazy stretch factor. All right, so the first thing you'd have to do, you come to this problem on a test. It's on the ACT test. Could be. They actually need you to know this kind of thing on the ACT. They only get 60 questions, though, and this one is only on there like once every, 5 years. Who knows? But it could be on there. First, you'd start by writing an equation that just has the vertex in it. Go ahead and do that. Just use the 2, 1 first. Everybody should be able to do that. And then you don't know the stretch factors, you put an A there. All right, I have an 8:15 alarm set because at 8:20, a bunch of you guys are going to leave. Sophomores who have English first or second hour. We obviously don't have English first hour, but are there any sophomores in here right now who have English second hour? All right, so it's just you. Okay, so that's going to be, you are going to take off at 8:20 to go to the Keith Hawkins thing. Let me read it to you. So you know exactly what you're supposed to do. Tenth graders who have English during first, which you obviously don't, or second period will be attending the 8:30 to 11:15 session. Please release these students at 8:20 to make their way to the East Gym. You've got to pick up your name tag, and obviously that's one of the ways they're going to take attendance, so don't forget to pick up your name tag, otherwise they're going to think, oh, she never showed up, and take a seat in this space. Make sense? All right. And that's in 4 minutes. Feel free to just get up and take off. Okay? 8:20. All right, so back to this. If you wrote this, y equals a, because we don't know the stretch factor, x minus 2 squared plus 1, now the rest will be pretty straightforward. Because you obviously have to put the 7 and the 5 somewhere. There's only one logical, can you put them in A? No, you can't put 2 numbers into one letter, so it can't go there. So hopefully you knew to put the x there and the y number there, and then you can solve for A. Go ahead and do that. But then at the end, you rewrite the same equation and you'll have figured out what A is. And it's like 7/5 or something. It's not 7/5, but let's say it was 7/5. Well, then your final answer is your equation looks like this. And you just have to figure out what A is. And it's not 7/5, but it's some fraction. All right. So Ethan T, help me again. Where am I supposed to put the 7 and the 5?
The 5 goes to the y's and the 7 goes to the x's.
Correct. All right, so now I have 5 equals A, and then I do 7 minus 2, which is 5. 5 squared is 25, plus 1. And then, what am I doing here? George, do you know what to do now? Got this A thing. 5 equals A, 25 plus 1. What do I do?
Minus 1.
You are correct. You're trying to get the a alone, so we're subtracting 1. Now we got 25a. And then, Garrett.
You divide by 25.
So now I know a. So here's my original answer, which was kind of right. I just didn't know a. So then you have to write the equation for me again. Y equals, except this time I know 4/25 is the stretch factor. X, and then minus, well, what's that? Oh yeah, that's where the vertex goes, 2, 1. So this is a 2 squared plus 1. It's the same exact thing we wrote in the first place, but we now know a. That was the hardest thing to learn today. I give you 2 points on a parabola. I got to give you the vertex or it just won't work. You have to know the vertex to do this. Okay. Now let's just a little review of yesterday, and then we'll hit the new stuff one last time to make sure it's stuck. Here's yesterday's stuff. I give you an equation and it looks like this. Negative x squared minus 4x minus 9. And you're supposed to be able to go, oh, I know that that one ends going up or down. And on the other side, it's either up or down. So hopefully you know which end goes where. Hint, look here first. And that tells you one of the ends. Then look here next, and that tells you if it's going to be the same or different. Then there was like 5 other things. How many terms does it have? This one has 3 terms. See, 1, 2, 3. What's the y-intercept? That's right there. What's the constant? It's the same as the y-intercept. What is the lead coefficient? There's a 1 there you can't see, but that would be the lead coefficient. What's the other coefficient? That one. That's a coefficient, it's just not the lead coefficient. And what's the degree? That's the 2. All right, so there's a whole bunch of stuff that we learned yesterday. All right, so let's see if you knew this one. That negative in the front, that means it must be going down on the right. Okay, so it must end going down like this. It's going down on the right. This 2 here, that's an even number, and even means the same. That means it's also going down on the left. Then this negative 9 right here, that is the y-intercept. Down here somewhere, you just call it negative 9, and you go, well, it must be going through that. And what it does in the meantime? Well, we know this one. It's a parabola, so we could know it goes like that. Do I know it exactly looks like that? Nope. It might actually look like this. Or it might look like this. But I know that it's down on the left and the right. Why do I know it's down on the left and the right? This one is the right end. This one tells me it's the same. If that had been odd, then I know the ends would be different. All right, so let's have you sketch this one. Y equals, no negative this time, x to the third minus 4x squared plus 2x plus 3. Just sketch it. You should know what the right end does. You should know what the left end does. And then I'm going to ask you some other questions like, what's the number of terms? What's the degree? That kind of stuff. So Sean, notice that it's not negative in the front. What does that mean? It's positive in the front. So up on the right. Very good. Ethan T, that 3 right there tells me something important. You know what it is? Yes. So right there, it has to go through that. Brady, this 3 right here tells me something. What does it tell me? Okay, if it's odd, it means opposite. So opposite on the other end, on the left end here, I had a choice of either it's up or down, and I want it to be opposite. So it's down. Good. So now you just have to draw me something that it ends this way, goes through that, and goes up here. That's good enough. Is that exactly what it looks like? No, but we'd have to get factored for him to do that, and we aren't doing that yet. If we had factored form, we'd know all kinds of things like, oh, it bounces here, but we don't know that yet. We're just working on what does it do on each end. All right? Still sensing weakness by kids I'm asking, struggling a little bit. So negative x to the fourth plus 3x plus 1. Sketch that one. In a moment, I'm going to ask you to compare your sketch with the kid sitting next to you. Don't get lazy. Draw it out. Yours won't look exactly like theirs, but will your ends be going the right ways? And will your y-intercept be correct? Okay, compare with the kid next to you. Okay, and now there's 5 little side questions that you should be able to answer about this on your next test. I hope you knew this was down on the right because it had a negative there, so it has to go end going down. It has to go through 1, and then it has to be even, so they must be the same. So it must be down on this side too. The simplest one that you could do would just be like this. That goes through the 1, and it's down on the right, and the same on the left. Okay, but now what's its degree? Brady, what's the degree? 4. All right. Anna, what's the terms?
4,
3. What's the lead term, Dominic? -1 is correct. There is a 1 right there. That's the lead term. What's the lead? Oh, wait a minute. Lead coefficient is -1. Dominic, I'm going to give you a chance to change your answer. Because if the lead coefficient is -1, what's the lead term? It's the whole thing. Right there. -1, x to the 4th. That's the lead term. I think maybe more than one person had that one wrong. -1, x to the 4th. The term is that whole chunk. Like this is a term, this is a term, and this is a term. Okay? So the lead term is that whole front thing. -1, x to the 4th. Yes?
How do you find like the vertex off of?
That's an excellent question, and that's the last thing I have to teach you, is that. How do you find the vertex for this thing? So, I have a little formula for you to memorize. Everybody write this down. X equals -b. Now, would you agree that there is a big formula that starts with x equals -b plus or minus square root b squared minus 4ac all over 2a? What's the very beginning of that? -b. What's the very end of that formula? 2a. And that is the smallest little formula that you have to memorize. We do not give this to you. But if you don't know this, you won't be able to figure out what the vertex is. Okay, go ahead. So, here is how you find the vertex then. If I give you this equation, sure, you could graph the whole thing. Wait a second. I just want to make sure that it has a decent vertex. There. Okay, so there's an equation. So what's the vertex on this one? Well, I got to know what A, B, and C are. There's A, there's B, and there's C. So x equals -b over 2a will tell you the axis of symmetry line. And that has to go through the vertex. Okay, so just one step at a time here. If B is -2, so we stick it there. And A is 2. So we stick that there. It's times, of course. Then I get negative negative 2, which is 2, over 2 times 2 is 4. 2/4 is 1/2. X equals 1/2. See? X equals 1/2 from that formula. That's the axis of symmetry. So how do you get the vertex? She asked me how to find the vertex, and I'm rambling on about this x equals thing. Well, it's because I just figured out the x of the vertex. Remember where this comes from? It comes from there. So still, Mr. Server, I haven't got the vertex yet because I don't know this number. Didn't I tell you what x to stick in? See? X is 1/2. Can't you figure out what y is? It's like an xy chart where I just told you that the x is 1/2, aka 0.5. So you'd go stick it in and figure out what y has to be. So here I do it. 2 parentheses 1/2 squared minus 2 parentheses 1/2 minus 1. And I know it's kind of gross, but that's y equals, and all of that will be my y. 1/2 squared is 1/4. So now it's 2 times 1/4. And then 2 times 1/2, well, that's 1, so it's minus 1. And then the minus 1 comes down. I got my another minus 1. Two times 1/4 is 1/2 again. Minus 1, minus 1. And can I just say minus 2? Minus 1 and minus 1 makes minus 2, doesn't it? So what is 1/2? You had 50 cents, but then you owe your brother $2. Your net worth then is negative 1.5. And that is that. That's the vertex. Now we just did a hard one because it had a fraction in it, but I just wanted to show you it's not that hard. That'd be the hardest thing we'd ever do. It's like put in 1/2. Normally you're going to get a nice number like 1 or 2 there. Okay. Let me give you another one, and I'm going to just do it really fast. See if you can keep up with me. You do not have to write this one down. Almost never say this, but just watch me for a second. X squared plus 4x minus 2. I want to know what the vertex of that thing is. It's x equals negative b over 2a. And what's negative b? That's negative 4. Over 2a, well, there's no number there, but there's a 1 there. So then this is 2 times 1, which is really 2. So then this is negative 4 over 2, which is negative 2. X equals negative 2 is the axis of symmetry. If they needed it, I'm already done with it. But if I want the vertex, I know that it's negative 2 comma something. And I'm not sure what the y is, so I go stick it here. I know x is negative 2, so you can figure out. We got an equation that says y equals, so that'll tell you what y equals. You just got to stick negative 2 in there. Now see how good my math is. Negative 2 squared is 4. And 4 times negative 2 is negative 8. These are always opposites of each other, which is kind of weird, but true. So 4 minus 8 gives you negative 4. Negative 4 minus 2. What's negative 4 minus 2? Negative 6. Did anybody beat me to it? Cool. That's the vertex. How'd I do it? I had this memorized. I think you can memorize that one. It's a really easy equation, negative b over 2a. Then I figured out the x, and then I knew that was the axis of symmetry and also the first part of the vertex. Then I stick it back in the equation to get the y value. All right. That's the other hard thing. Honestly, I suppose you could argue that it's just as hard as the other thing I taught you earlier, but the challenge with this is that you've done it before. In higher algebra, you learned x equals negative b over 2a. How many of you feel like, yeah, I've seen that before? Yeah, I think you did. Okay, so the only thing that was really new today, that wasn't just a review of higher algebra, was the one where I give you 2 points on a parabola and you have to figure out the equation for it. So, all right, so here's your little formula. I'm leaving it on the screen, but you have to memorize it. And here's a typical question. 2x squared plus 8x minus 1. And they say, what's the vertex? First figure out the axis of symmetry, because it'll tell you the x. Then figure out the other part of the vertex. You can do it. So Greta, we obviously have to figure out negative b. So can you start us here?
Put 8 in
Yep.
for b.
So it's negative 8, right?
Yeah.
Over 2 times a, which is 2 times,
2.
perfect. Negative 8 over 4, negative 2. How many of you already had negative 2? Cool. Then you have the first part of the vertex. Now stick it in the equation to figure out the other part. Because it says right here, y equals, so it'll tell you what y equals. All right, I'm going to put it here and here. And in a second, I'm going to have you crunch your numbers. Tell your partner what you think the vertex is. Negative 2 comma what? Don't say it. Tell them when they're ready. Okay, so negative 2 goes in. And that's right here and right here. And then that's 4 times 2 is 8. And that's negative 16. Remember me saying they're always opposites? It's weird, but it's true. So then putting them together gives me negative 8 minus 1 more, negative 9. Negative 2, negative 9. Who had that one right? Cool. You now know how to find the vertex of any parabola. So on the worksheet, they just do one thing that like really messes kids up, but it's actually so simple. And the kids are like, well, then that looks different. I don't know what to do. Well, it is different. All you have to do is rewrite it so it's in the right order. And then you'll know A, B, oh, B is actually the number in front of it, right there, and C. So this, I know it looks different, but you just have to rewrite it so that it is in the right order. And then you'll know what A, B, and C are. And then you can do, if you wanted the vertex or the axis of symmetry, you'd start either way with the x equals negative b over 2a. And here it would be negative, that's a 1, over 2 times negative 2. So there's 2 negatives, so those cancel. So then this would be 1/4. So my vertex on this one would be nasty because I got to put a 1/4 in the equation. But it's not impossible. You put a 1/4 in here or here. And then you simplify it down and you figure out what y is. Okay, and then one last one like we started the hour with. I want to actually do one from the notes here. So everybody go to all right. If you had to graph this, it would look really scary. But do you get, we're on page 4 of the notes, do you get the vertexes just negative 3 comma 4? It's not that bad. So negative 3 comma 4 is the vertex. So I go to negative 3, negative 4. And I know it's a right side up parabola. Oh, wait, no, upside down parabola. So I know it kind of looks like this. How do I find some more points? XY chart. You stick in any numbers you want, like usually close to here. So then you put in like negative 2, maybe negative 1, maybe negative 4, and you find some points. Just a reminder on how to graph. Anytime you graph, you just find a bunch of points. And you'd end up going, oh, I see. It connects through all these dots. And then if you know which direction it's going, because the negative in front told you it was upside down, you just have to find a few more points. All right. So we're going to go all the way to there we go, page 10. We have done this twice. Can you write the equation for this, just knowing the vertex, and then put an A where the stretch factor is? Then you stick this point in your equation and you can solve for A. Try that. This will really set it in stone that you learned the big thing of the day. This is really the only pre-calc. Otherwise, it was just a review of higher algebra. Now granted, it was a week worth of higher algebra that you reviewed in a day. Okay, how does this go again? I got x, and then I go minus 1 squared plus 3. That's me taking the vertex and making this thing. But I don't know the stretch factor, so I put an A there. Greta, can you tell me where to put the 0, 5?
Put the 0 in for x and the 5 in for y.
Yup. And now I can solve this thing. 5 equals A, and then all of this will simplify down. 0 minus 1 is negative 1. Negative 1 squared is just 1, and 1 times A is just A. I could put a 1 here if it makes you feel any better. And then plus 3. And then I subtract 3 from both sides. And I get 2 equals A. A equals 2. So then, what's the final answer? It's the equation we wrote in the first place. X minus 1 squared plus 3, because that has the vertex, right? Except now we know the A is 2. We will practice this again, but do you feel like that's one that'll be easy on the test? Good. I don't feel like that's that hard. I know I'm biased, I'm the teacher, but you can sometimes tell if tons of people are struggling versus, I think there's only a few people that are struggling on this one. Remember, you can always ask for help. All right, so we have a worksheet. So everybody pull that up. I'm going to cut it down to a very reasonable size because a little practice tonight is so much better than just taking the night off of math. Just a little practice, just like a couple problems. All right, so open up that worksheet. Can I look at yours? Let's do the first problem together to get it rolling. Could you just read me the directions first?
Describe how to transform the graph of f of x equals x squared into the graph of the given function. Sketch that graph by hand.
Okay, so give me the actual function then.
G of x equals x minus 3 squared minus 2.
Minus 3 squared minus 2. All right away I'm going to the vertex. But wait, it said which way has this been moved? Don't forget this. That means right 3. What does that mean? Down 2. That's when they're talking about, like, which way has it been moved? That's what they're talking about. It's like this used to be y equals x squared, but we tweaked it, and we moved it right 3 and down 2. Okay. Now, what else did they want besides, like, where it's been moved? You want me to sketch it?
Yeah, to sketch the graph.
Okay, so for a sketch, you just make an XY axis like this, and you go, well, I know I go to 3, comma 2, because that's the vertex, or 3, comma negative 2, sorry. So you graph that point, and then you either know it's a right side up one, or it's an upside down one, and since there's no negative in front, it's right side up. That is good enough for a sketch. If I actually made you find a whole bunch of points on an XY chart, that would be called graphing. That's the difference. Graphing it, I'd need you to find 5 points. You know, you'd stick in like, okay, I'm going to stick in 3 because that's a good one, and I get 3, negative 2, and then you got to find 4 other points. And if you did, they'd just all be like this. So this is a sketch, and it's good enough. All right. So let me take a look at it again to see which ones we should skip here. Thank you. We're gonna skip 7, 8, 9. 12, 14, 15. 7, 8, 9. 12, and was it 14, 15?
14, 15.
What?
Yeah, 14, 15.
12, 14, and 15, okay. That's a lot of skips, but I also know, I talked to some colleagues, and they said, we're not doing the part with the calculator this year. We're not doing linear regression after all. Sorry about that, but it was in both of the, on day 1 and day 2's worksheet. It's just some of the people had talked and agreed, we're not gonna do that this year. So I didn't know that, nobody told me that, so now I know. So I guess we're not doing that stuff that you need a calculator for, so. So we may not end up using calculators for this unit after all. We probably will on some upcoming unit. We all want you to get some practice using the calculator, but looks like not this one. All right. Gotta admit, if I'm having you skip 7, 8, 9, and 12, 14, and 15, I'm trying to keep it reasonable. That should make it be just finish some in the class, go home and do a couple at night. That's doable. All right, that's all I have for you for today.